Alright, we're going to try to get this 3.1 solving quadratic equations out of the way. Investigating ways to solve simple quadratic equations. There are many different ways we can solve quadratic equations, both algebraically and graphically. Alright. We could solve this by taking the square root of both sides. When you do this, you got to remember, anytime you take the square root, your answer could be both positive and negative the other side, right when you get down the square. And you can also do this by graphing. So if I graph x squared equals 16, I can graph a solid line at 16. That would be my g of x equals 16, and then I could say f of x equals x squared, much like we did before. Just graph these two separately. And if I do that, I go square root of 2 is 4, square root of 4 is 16, square root of negative 2 is 4, square root of negative 4 is 16, and I can once again just see where those, I missed a little there, once again just see where, I'll try to pull it in here, and there we go, cross, and that would give me x is 4, x is negative 4 in both those situations. Alright. What method would I choose here? If I try to graph x squared equals 5, that would be somewhere around here, right there. It's really hard to tell what that is, so I would probably choose algebraically and give myself x equals positive or negative square root of 5. And I actually don't know what that is. It's probably 2.2, 2.3. But why? Because the graph is not on an integer, right? I can't really tell what it is. I have to make a guess if I do a graph, whereas, you know, positive or negative rad 5 is the exact answer, right? So, can the equation x squared equal negative 9 be solved in any of these methods? Well, think about it. Negative 9 is way down here. Definitely can't be solved graphically. If I take the square root of both sides, I get x equals positive or negative square root of negative 9, and I don't know what that is. Well, actually I do, but you don't know what it is yet. So we're going to say no real solutions. And that's going to become a bigger reason later on, the fact that we said no real solutions. But there just aren't any solutions that we know of. All right. Let's go ahead and this is the other side too. All right. Now, I can solve simple quadratic equations by taking square roots. And when they're simple, this is really how you want to solve it. All right. So when solving quadratic equations in the form of ax squared plus c equals 0, that means there is no bx. What we're missing here is bx, right? It's just a square and a constant. You may not always end up with a perfect square, but in these cases you will need to use the properties of square roots to, we're going to say reduce the solutions. For instance, there's a product property, which means if I have a product of two, well in this case variables underneath there, right, or two elements, I can break that up into the square root of a times the square root of b, right? And the quotient means I can do the square root of the top over the square root of the bottom. So what you're looking for is something that's a perfect square. I know 12 is square root of 4 times the square root of 3, and I happen to know the square root of 4 is 2. I don't know the square root of 3, but I've simplified it into 2 rad 3. This one right here is the square root of 5 over the square root of 9, and I know the square root of 9 is 3, so that's rad 5 over 3. This format's kind of important. Alright, you're always going to want a non-radical in the bottom. Alright, so when applying quotient, we're going to talk about that right now actually, when applying quotient property of exponents, we cannot have an irrational number left in the denominator. Alright, this means we cannot leave any imperfect roots in the bottom. When this happens, we need to do something called rationalizing the denominator. What you do to rationalize the denominator is you multiply by 1. So watch me multiply by 1. Rad 3 over rad 3 is 1. But it does something nice. It changes the bottom into, well, we got 2 rad 3 up top, but it changes the bottom into radical 9, which we know is just 3. There it is. And when I come over here, let's try to get this. All right, 2 rad 5 over rad 7. I'm going to do the same thing. I multiply by rad 7, multiply by rad 7. That is just 1. All right, I'm really multiplying by 1. And the top is going to be 2 rad 35. Nothing reduces out of there. And the bottom is just 7, right? Square root of 49. Same thing here, but I can do a little bit more here, right? I can rewrite rad 6 as rad 3 times rad 2. And then on the bottom I have 3 rad 2. And these two cancel off. And I've got rad 3 over 2. So I'm going to go through a few more of these. I'm going to show you a method I like calling you have to have a date to come out of the house. So here's one method. If you do a factor tree, since we're looking for square roots, right? Square root just means what two factors make the bigger number. And sometimes there aren't any. Like I don't know what two factors make 18. Because there aren't any. But within 18, there are perfect squares. And if I go 2 and 9, and 9 breaks down into 3 and 3, those 3's are a pair. They're actually the square root of 9. So anytime you have a pair, you can circle them and bring them out. And whatever isn't paired up has to stay home. B is kind of easy because we know both square root of 25, which is 5, and the square root is 49, which is 7. Let's do 75 the same way. 75 is 3 times 25. There's one prime factor. And 25 is 5 times 5. And once again, I have pair. I'm looking for pairs of factors because I'm doing square roots, and I get 5 that comes out of the radical. Square root of 3 stays in. All right. Come over here and I'll break this 48 down. I like to do 2's. 2 and 24. Which is 2 and 12. There's one pair. Which is 2 and 6. Which is 2 and 3. There's another pair. So these 2's come out. And that gives me 2 times 2, which is 4 radical 3. This guy right here, I'm going to reduce square root of 64, which is 8 over rad 7. Right? Rad 7 can't stay like that, so I multiply top and bottom by rad 7. And I get 7 on the bottom. 8 rad 7 on top, and I'm done. Last one. I'm going to reduce this a little bit. Right? I'm going to write 27 as the square root of 3 times 3 times 3. On the bottom, 24 is the square root of 2 times, oh my goodness. Maybe I'll do 1, 3. 3 times 2 times 2 times 2. These 3's cancel out. So what I get is I get the square root of 9 over the square root of 8. Right? Since I've already broken down, we'll break it down again. We're going to go 2 and 4 and 2 and 2. 2's come out here. So the top is just 3 so far, but the bottom turns into 2, the 2 that come out, rad 2. Again, I can't have a rational in here. I'm going to multiply the top and bottom by 2. There's a lot going on in this problem. They have a pair, they come out and multiply to that 2. That gives me 4 over 3 rad 2, and I'm going to pause and stop. There's the first page. Talk to you guys soon.